Use dimensional analysis by including all units throughout your computation to answer each question. A. The doctor orders 2 milligrams of Valium to be administered IV intravenously to a patient experiencing seizures. You have a 5 milliliter vial that contains 10 milligrams of Valium, i.e. 10 milligrams per 5 milliliters. How many milliliters are you going to draw into a syringe and push into your patient? Reminder, include all units throughout your computation. So the goal is to make 2 milligrams. So let's start with that as our beginning number. So 2 milligrams. And we're trying to figure out how many milliliters. So we'll circle that. That's the goal. So we're trying to go from milligrams to milliliters. So we know we're going to multiply by a fraction. And the fraction is supposed to cancel the milligrams that we already have. So the question is, do we want to put milligrams here or here in order to make it cancel? And hopefully we see that milligrams up on top needs something on the bottom to cancel. So that isn't where we want to put it. We want it on the bottom. So let's put it on the bottom. So we'll put milligrams in the bottom. And then the only other unit we have in this problem is milliliters. So I guess that's what we're going to put on the top is milliliters. And hopefully we have some numbers that we can put in front of both of those units, and I think they're circled here in green. 10 milligrams per 5 milliliters. 10 milligrams is actually on the bottom, per 5 milliliters is now on top. So it's just the reciprocal of that fraction that's circled in green. But writing it in this order allows us to cancel milligrams with milligrams, which leaves us with milliliters, which is just spiffy because the goal was milliliters. So we do our multiplication. 2 times 5 on the top is 10. Divided by 10 on the bottom. And that leaves us with 1 milliliter. Of course, it might have been really easy for some of you to recognize that we just needed 1 milliliter based on the numbers in this problem. But the idea here is to practice with dimensional analysis, which is why we wrote everything out. Moving on to part B. A taxi ride in Italy costs a flat fee of 2 euros plus another 0.25 euros for each tenth of a kilometer driven. Approximately how many dollars and cents? Okay, that's just terrible. I don't know how I used the wrong word for cents here, but I'm crossing that off. It makes no sense why I would misspell that word. Approximately how many dollars and cents would a 4-mile ride cost? Hint: 1 euro is worth about $1.78 and 1 kilometer is approximately 0.6 miles. Reminder, include units throughout your computation. So we'll begin with the only, sort of given information about our specific ride in this taxi cab, and that's the 4 miles. So we're starting with 4 miles and hopefully ending with some number of dollars and cents. So we're going to be multiplying by fancy forms of 1 here. So if I have miles on the top and I want to get rid of miles, then I better put miles down here. So what are the 2 units that I have, one of which is miles and the other one kind of compares to miles? Let's see, it says 1 kilometer is approximately 0.6 miles. So that tells me that kilometer is the other thing that we're going to put in this fraction, because underlined in red is this relationship between kilometers and miles, and we'll just use those numbers that are given. 1 kilometer is about 0.6 miles. Okay, so far so good. So we can cancel those guys there. So now we're up to kilometers. And that's good because that kind of opens the door to this particular ride, because the ride is given in terms of how many kilometers you go. So it says for each tenth of a mile, for each tenth of a kilometer, we're going to have, let me use a different color there. For each tenth of a kilometer, this ride is going to cost us 0.25 euros. So I think that that's another unit that we can, or another fraction we can put in here. Multiply this by some fraction. Currently I have kilometers on top, so that tells me I better put kilometers on the bottom to cancel. And what's circled up there in black tells me that I can convert between euros and kilometers. So we're going to put euros up here. And now according to what's in black, each kilometer, each tenth of a kilometer is 0.25 euros. So I think it's fair to write that fraction and to say that that fraction is basically equal to 1, because every 0.25 euros is equivalent to a 0.1 kilometer ride. Okay, still canceling. We now have an amount of euros. That's for the like driving part of it. but then there's this flat $2 fee, this euro, just getting in the car, getting in the cab costs you $2 right off the bat. So I think we're going to add to that €2. No need to convert everything or anything because both of these things now are in euros. After all the canceling, the entire big thing that we calculated already was euros, and then we're going to add €2 to that. So ultimately, we can smush these things all together in order to find how many euros we have. So let's do that, and then we can go from euros to dollars and cents. Okay, so we're starting with 4 and then multiplying it by the 1 divided by 0.6. 4 times 1 divided by 0.6, and then multiply by the 0.25 divided by 0.1. And then to that, we're going to add the number 2. So crunching that all together, we get 18 2/3 euros. So I'll abbreviate that or approximate that, I guess, with 18.67 euros. And then we're going to go from that number to our final answer, which is going to be in dollars and cents. So brand new calculation, new thought, 18.67 euros. And now we're going to get to dollars and cents. So I'm going to multiply by a fraction. And I want euros to cancel, so we better put euros down there, which I guess means dollars is going on the top. And then what's given to us here now is that 1 euro is worth about $1.78. 1 euro, $1.78. And then we can cancel the euros. And we're ready to do our final calculation here on the calculator. So it's just the 18.67 times the $1.78. But instead of retyping 18.67, let's just hit times, and then we'll have all the digits that are shown in the calculator, not rounded like we'd written down. And so we multiply those together, and we get 33.227, which we can round to $33.23.